This is a perfect hybrid thermal panel or HTS panel. Simply put, the HTS panel takes in thermal energy from the sun and does partial work for the compressor, thereby reducing its load. The reduction in compressor load reduces its RPM, saving up to 40% in electricity bills. Now, let us understand how this works. Here you can see the diagram of a normal VRV air conditioning system. In our system, the refrigerant gas from the outdoor unit will enter the HTS panel, run along the length of the panel and come back to the unit after absorbing energy from the sun. The HTS panel has 6 parabolic reflecting surfaces with copper pipes running along its focal point. The sun rays get concentrated at the focal point, heating up the copper pipe. These parabolic reflectors are always pointed at the sun using actuator motors and a sun tracking diode. The brain at the bottom of the HTS panel decides how much heat the system requires and makes sure there are no issues in the air conditioner. This is how a conventional air conditioner works. The compressor, situated in the outdoor unit, consumes the highest amount of electricity in the system. It compresses the refrigerant gas, thereby increasing its temperature and pressure up to saturation point. This gas is then pushed into the condenser, which is again in the outdoor unit. Here, the ambient air cools this gas using a fan. The gas then travels from the outdoor unit into the indoor unit in copper pipes. Next comes the expansion valve at the indoor unit where the liquid refrigerant expands and the pressure goes down. The gas then enters the evaporator, again in the indoor unit, where it removes the heat from the room, causing the room to cool down. From here, the gas again goes into the compressor. There are two major parameters in this system which constantly change. First is the outdoor ambient temperature, which when increased, reduces the efficiency of the whole system due to reduced heat removal. Second is the indoor room temperature, which varies with the number of people in the room. VRV is the current widely used available technology where the fixed compressor is replaced by inverter compressor. As the room temperature nears the set temperature, the RPM of the compressor reduces, thereby saving energy. In VRV technology, only one half of the system is made efficient, which is the evaporator side. We have here a technology which takes care of the condenser side. Now, let's understand how the system works with the HTS panel. The gas from the inverter compressor enters the HTS panel. Here, the gas absorbs heat from the sun as explained earlier in the video. Due to this heat absorption, it improves the delta T, thereby improving heat removal at the condenser, which is especially useful during high ambient temperatures. This also stops the degradation of capacity. This further heated refrigerant gas is returned from the panel outlet onto the AC's condenser. As explained earlier, the job of the compressor is to increase the temperature and pressure of the gas. Now, the HTS panel does partial work for the compressor using the heat from the sun and hence, the RPM of the compressor reduces significantly. The thermal energy added to the system by the HTS panel correlates with the amount of energy saved by the reduction in compressor RPM, allowing the components to operate at lower loads while providing equal or better cooling. This reduced RPM reduces faults in the system, reduces noise in the system, increases life of the system, and of course, most importantly, reduces electricity consumption by 40%.